Now let's talk about the fourth rule, which is division rule. It's quite simple but a bit lengthy. It is used when we are given function something like that, y is equal to sin x upon cos x. That is, two small functions of x are given in this form, that is in ratio form. Right, in this case we have to use division rule. What we have to do here is, let's call this function to be the function in numerator, this function to be the function in denominator. Then if I want to differentiate any function which is given in form of numerator upon denominator, then what I need is I need to make denominators square. Now denominator as it is, differentiation of function given in numerator minus numerator, function in numerator as it is, and then the differentiation of function given in denominator. So if you proceed this way, then you'll get the differentiation of above function. Let's solve the above question, that is y is equal to sin x upon cos x. Although it is actually 10x and its differentiation, we know directly that the differentiation of 10x is simply sec square is x. Let us verify it by calling cos x to be the function given in denominator and sin x to be the function given in numerator. Now if I differentiate above relation, then what I'll have to do is square of cos x, that is the function in denominator as it is. Now differentiation of numerator, which is differentiation of sin x is cos x, minus, now I'll have to keep numerator as it is, and numerator is simply sin x, so sin x as it is, and now I'll have to differentiate denominator, and in denominator I'm given cos x. Now if I differentiate the function that is cos x given in denominator, then what I'll get is differentiation of cos x is minus sin x. If I solve it, then what I'll get is cos square x plus sin square x upon cos square x, and this will simply result in 1 upon cos square x, that is sec square x. We knew the differentiation directly, that the differentiation of 10x is simply sec square x, and by proceeding in this manner using division rule, I'm getting the same result. Let's take a couple of more examples which could be solved by this. For example, let's take something like x square upon sin x. If I need to differentiate it, then I'll have to call it the function given in numerator, and this sin x to be the function given in denominator. Now if I differentiate y, then I'll get square of denominator means sin x as it is, differentiation of numerator, which is 2x, minus, now I'll have to keep the numerator as it is, that is x square as it is, and differentiation of sin x, which is cos x. So what I get is sin x into 2x minus x square cos x upon sin square x. So this is the answer of above problem. Let's take a couple of more examples. For example, if I am given a question like this one, e to the power x upon, let's say, x square. if I have to differentiate above function, then what I'll do is square of denominator, that is square of x square as it is, differentiation of e to the power, which is e to the power x as it is, minus numerator as it is, and differentiation of denominator, which is 2x. So what I get is e to the power x common, x square minus 2x upon x to the power 4. Now I can, if I want, I can take x to be common, then what I'll get is x minus 2 upon x cube. So this is the answer of this problem. Let's take one more example. These examples are very similar, just formula based. I'm just using the formula, that is square of denominator as it is, differentiation of numerator minus sign numerator as it is, then the differentiation of denominator. For example, if I'm given something sec x by, let's say, x square, then if I want to differentiate this relation, I can easily see that this could be solved by using division rule. Now I have to put square of denominator as it is, differentiation of numerator, which will be 10x sec x 10x, minus this time numerator as it is, and differentiation of denominator, which is 2x. So what I get is sec x common, x square 10x minus 2x sec x upon x to the power 4. Simple. So this way we have understood this rule, which is the division rule.